Hello guys, welcome back to Gregorius Maths. Today we'll be proving one of De Morgan's laws, which says that the complement of A union B equals the complement of A intersect the complement of B. And, well, what's the complement? Well, the complement is, so if we have some set S being the set of the first three natural numbers, and then the set A being the set of the first two natural numbers, then the complement of A in S is the stuff that's in S but not in A, or in this case 3, and therefore the complement of the complement of A is always A. Okay, and when I just write it like this, the S is implicit of, it's just some set S, so that we don't always have to write C of S. Like when we write ln or log, the base is implicit unless there's some other set that we want to take the complement of. And then what does union mean? Well, if we have a Venn diagram, A, B, well then everything is A union B, because it's either an element of A or an element of B, the shaded region, or an element of A and B, which is still A union B. But then this backwards U or N kind of looking thing means intersect, which is just the shaded region here. So that equals A intersect B, this shaded region. Basically the stuff that's in A and also in B. So now that all of the explanation is done, we'll get into the proof. So suppose that X is an element of the complement of A union B. That means that X is an element of S, some set, right, by definition, but also X is not an element of A. X is not an element of B, and therefore X is an element of the complement of A, right? Because it's the stuff that's in S but not in A. But also X is an element of the complement of B. So X is an element of, well, it's in both complement of A and the complement of B. So using our new vocabulary, it's in the complement of A intersect the complement of B. So this means that the complement of A union B contains the complement of A, oh that's really bad, contains the complement of A intersect the complement of B. Okay, and to prove that these two are equal, we just have to prove that the complement of A intersect the complement of B also contains the complement of A union B. And if we can prove that, then we're done. So let's just suppose that some other x, completely unrelated to this x, just some x is now an element of the complement of A intersects the complement of B. This means that x is again an element of S, some set. X is also an element of the complement of A. X is also an element of the complement of B. But this means that x is not an element of A, x is not an element of B, and therefore x is an element of the complement of A union B. Because it's not in B and it's not in A, so it must be a complement of A union B. Okay? So this means that x, oh sorry, no, now x has nothing to do with it. This just means that the complement of A union B is contained in the complement of A intersect the complement of B. But we've also proved, so we've proved in two different ways that they contain each other, so they must be equal. Therefore, the complement of A union B equals the complement of A intersect the complement of B. Q, E, D. Okay guys, thank you guys for watching. Hopefully this is a lot more clear now, and in the next video we'll be proving his second law, which is very similar to this one. See you guys in the next video. Bye.